Hi everyone, Happy New Year. I'm Dr. Kyung Park from Implant Dental Clinic, South Korea. It's been a really while since my first lecture last year. I'm so sorry that I couldn't keep the promise to upload the videos. However, I promise to upload the videos continuously from now on. Right, let's get started. As I said at previous lecture, the currently using fixtures are surface tilted and half threads. So what is obtained is compromised osseointegration, not the original osseointegration. I didn't know exactly about osseointegration before there was an incident that made me realize the difference between the two. One day in the past, I had very hard time removing failed fixtures because they didn't fall out easily. So after a while, the fixture was removed with the bone fragment attached to the cutting edge of them. I wondered how good the integration was. So when I tapped the bone fragment sideways, then it ridiculously it was too easily separated from the fixture. In other words, there were no bonding force acting upon the bone and the fixture. It's just the way they were in very close contact with each other. However, the fixation was so solid, the bone fragment ripped off from the alveolar bones, and the cutting edge of the removed fixture was machined apart without surface treatment. At that moment, I saw the surface of torn-off bone fragment which was in contact with the machined part. I realized it was the original osseointegration surface, unimaginable and not a natural bone surface, so-called shiny surface, which is so hard enough to endure any strong occlusal forces. Last time I mentioned, due to the surface treatment and stress on fixture, alveolar bone and the fixture are not in contact with each other mesiodistally. From now on, I explain the reason. Surface treatment first. Surface treatment is nothing special, just making a subtracted surface that is subtracted and roughened by the blasting and etching process. Its purpose is to gain the wettability of blood because blood sticks easily to the roughened surface and eventually form the blood clot wear. As a result, good blood clot formation around the fixture promotes and accelerates the bone growth and leads to a low possibility of integration failure. But there has been also misunderstanding about subtracted surface. That is, mechanical bonding between the fixture and alveolar bone can be obtained on this subtracted surface like this. In this part, I'd like to emphasize again about original osseointegration that the bones and fixture are just in very close contact with each other, not coalesced together, and there is any other bonding force acting upon them. That's enough. No need of mechanical bonding force. For easier understanding about the original osseointegration, I want to compare the fixtures to the King Arthur's Excalibur. It's about the myth though. But let's think about why nobody could pull it out with strength. That's because there was no gaps around the sword in the hard rock. So it was impossible to even shake the sword. Needless to say, if there were mechanical bonding, it would be better. So let's see that's going to happen. This magnified photo represents the smooth machined surface that looks bright and white. And these photos are also the highly magnified surface of RBM and SLA with a roughened texture after subtracting process. So they look dark and black because the light is not reflected. So if we scratch it something like a coin, it becomes smooth again, turns to look white because the light is reflected. That means the black area is not a separate layer, just the same titanium layer as this smooth area. So the osseointegration takes place on this smooth surface too, although it's not easy to get an integration. RBM looks darker than the SLA because surface of RBM is rougher than SLA. The rougher the surface, the darker the color. Only an additional corrosion process by strong acids is performed to RBM surface to make the SLA surface that is less rough, which is because the RBM method was pointed out as follows. That is, bone formation smaller than the size of 0.1 mm does not occur. So, acid corrosion is carried out to make the small irregularities into the bigger ones in order to promote microscopic bone growth. However, can you see a noticeable change of size of irregularities? I can feel only small change of average size and just the opening of irregularities widen overall. The diameter of yellow circle is 0.1 mm. You can see a lot of irregularities coming into the circle, which means the size of irregularity is still smaller than 0.1 mm. And there is no big difference between the two. Therefore, I think SLA is a little bit better than RBM in terms of microscopic bone growth. Of course, it may be different depending on specific product because the technology of manufacturer may be special. However, this is general theory. Anyway, let's look at this picture for easier understanding. On the surfaces of RBM and SLA, a bundle bones form around the fixture circumference, but microscopic bone formation does not occur. So, fixture and alveolar bone are not in a lot of contact with each other on both surfaces. However, SLA may be a little bit better than RBM. On the other hand, they are in a lot of contact with each other on the machined surface. Now, if you look at the final result of integration on subtracted surface, there is no mechanical bond between the fixture and the bones. Furthermore, the subtracted fixture is in much less contact with the alveolar bones than the machined fixture. So we get this advantage of decrease in fixation force. Instead, we get the advantage of lower failure rate. So that's why I call it the compromised type of osseointegration. Therefore, I mentioned the surface treatment is the first reason why the fixture and the bones are not in contact with each other mediodistally. Now, I'll move on to the second region, threads on the fixture. The threads of fixture and screw nail what we often show around are similar and different in some ways. The similar point is the both are right hand screw. If it's rotated in clockwise direction, the insertion proceeds while moving forward automatically. The difference is while the screw nail is engaged within the insertion object, between the threads, they are mechanically coupled and fixed immediately. But the fixture is inserted living tissue called alveolar bone and not fixed between the threads right after implantation. And then it will be fixed after going through a process called osseointegration. However, if you look at the result after integration, unlike a screw nail, in most cases, there is no bone growth between the threads, so you don't get the mechanical fixation mesiodistally. For your reference, the height of a thread is called depth, and the gaps between the thread is called the pitch, which is usually above 0.6 millimeters. Previously, there was an experimental report. Microscopic bone formation smaller than 0.1 millimeter is impossible. However, most clinical results show us even the 0.6 millimeter sized bone formation is not common in human alveolar bones actually. If there were bone growth between the threads, we could get the mechanical bonding even though there is no contact on the subtracted surface overall. However, actually, in most cases, there is not that much bone growth between the threads, so there is a conclusion we cannot get the mechanical bond between the threads and also make the less contact with the bones. For this reason, I think in some ways the threads are also another type of surface treatment because they make the bad contact even worse. In other words, they can be regarded as a greatly enlarged roughness. Therefore, the presence of thread is the second reason why alveolar bone and fixture cannot be in contact with each other mesiodistally. Anyway, to compensate for the reduced fixation forces, there is a trend to increase the pitch of threads for the easier bone growth between the threads in order to get the mechanical bonding more than before. Some of them only pitch increased while others have both increased. However, the actual results show bone formation between the threads depends on the patient's bone quality. If the bone quality is bad and the depth of thread is small, we still cannot get the mechanical bonding between the threads. But if the depth of thread is large between the threads, we can get some bone growth. However, as I said earlier, because of surface treatment, they are not in contact with each other overally. If you look at in detail, it will be so at these areas. So there is not a lot of mechanical bonding as much as expected. However, in the bone density is very good. It's also possible to get some mechanical bonds between these small depth threads. Whatever, right side fixture is better than the left side fixtures in terms of mechanical bonding between the threads. And both have their own disadvantages though. I'll tell you at the end of lecture.